All right, guys, so we're going to be moving on to the last section here, which is 5.7, inequalities in two triangles. This one is going to be more application type problems, but again, I think we're going to do fine with this. Obviously, if you need help as you get into this, reach out to us and let us know that you're having issues, but we're going to work through some examples here, trying not to make this video as long as the last one, but I do want to get some information to you. So let's consider this first part. It says consider triangle ABC and XYZ, which are right over here. It says if AB is congruent to XY, which is, we kind of already know that because they're giving us congruency marks right here to tell us that those are the same. It also says that BC is congruent to YC, which again, they're giving us a different set of congruency marks. So what they're saying is this is a different length than this, but these two are the same. So notice that we're comparing one triangle to another. And that's kind of what you're doing all throughout this particular subject. That's thus the reason it's entitled Inequalities in Two Triangles. So then the other thing that it's telling you, which is really, really important, is the measure of angle Y is greater than the measure of angle B. So what they're saying is, for example, let's say that this was 91 degrees, then this would have to be like 89 degrees, okay? Because this angle is bigger than that one. That's basically the information that they're giving you. This theorem, this is called the hinge theorem, and it's basically saying if angle Y is greater than angle B in this situation and all of these sides are the same, then it's telling you that XZ also has to be greater than AC. So what they're saying is that this side then, and I'm just going to use some arbitrary numbers, but this side, for example, could be 10, then this side would have to be something like 9, okay? So what they're saying is if you got two triangles that are exactly the same, in other words, these sides are the same, these sides are the same, yet this angle is bigger, then this side is also going to be bigger. So it goes right back to what we were talking about yesterday with the door and the door frame. That's basically what the hinge theorem is, okay? It's basically just saying if you're comparing two triangles and the sides are the same, yet the angle in between them, notice it says side angle side, but the angle in between them, one of them is bigger than the other, then that side's going to be bigger than the other, okay? So it kind of makes perfect sense in that concept. So let's look at a couple problems here at the bottom, which I think are going to help us to really understand kind of how this works. So look at the question, and here's what you're going to have to do more than anything else. If you listen to anything you hear on this video, listen to this. You're going to have to read your instructions. Take your time, read your instructions, see what the question is really looking for, okay? And you'll see this once you get into Form G, into our practice. So notice what it says. It says, what is the inequality relationship? So inequality relationship. We know inequalities are less than or greater than, right? Or less than, equal to, greater than, equal to. So we know that these kind of symbols are going to be involved some way or another, okay? So it says, what is the inequality relationship between LP, which is here, and XA, which is here, in the figure to the right? So it's looking for a relationship between LP and XA. So watch what I'm going to do here. I'm going to go ahead and put LP, and I'm going to go ahead and put XA right there. Now, what I have to figure out is what needs to go right there. One of these two symbols is going to have to go there, right? Either LP is greater than XA or LP is less than XA. Well, how are we going to figure that out? Well, notice what you have. You've got congruency marks here, which means those sides are the same. You've got congruency marks here, which means those sides are the same. The only difference is here you have 93 degrees for angle Y, which is the angle in between the two sides. Here you have the 90-degree box, right? You've got the right angle box. So I know that that one has to be 90 degrees. So then I'm asking myself this question, is LP less than or is it greater than XA? Well, LP right here, excuse me, has to be less than XA because it is the angle across from that side is 90 degrees, whereas the angle across from this side is 93. So if this is 93 degrees, this side has to be bigger. I don't know exactly what it is, but I don't really have to know. All I have to know is that LP is less than XA, okay? So that would be the final answer for that particular problem. Now let's look at number 2. Number 2 says, at what time is the distance between the tip of a clock's hour hand and the tip of its minutes hand greater, 5 o'clock or 5:15? I'm going to be honest with you. Again, I'm a visual person, so I'm going to have to draw me a little clock. So actually, I'm going to have 2 clocks, right? So one clock is going to show 5 o'clock. So if you notice on the clock, you've got the 12 here and the 5's about right there. We can kind of estimate that. So the minute hand would be here, and then my hour hand would be right there, right? So what it's talking about is this angle right here, right? At what time is the distance between the tip of the clock's hour hand and the tip of its minute hand greater? So we're actually talking about this distance right here, but you notice I've got my angle kind of drawn out there. Now let's go ahead and do 5:15. Let's think about this. So at 5:15, I've still got my 5 here, but 15 after is where it's at the 3, right? So notice what I have. Here would be my minute hand. Here would be my hour hand, right? The hands doesn't change. They're the same, but the angle between them would change, right? So this angle here is what we're talking about, and this side length. So the question is, at what time is the distance between the tip of a clock's hour hand and the tip of its minute hand greater, 5 or 5:15? Well, the distance between the two hands is obviously greater right here, okay? So at which time? The answer would be 5 o'clock. At 5 o'clock, the distance is greater, right? So that's the way you have to kind of work out these problems. And you're going to see this again as you get into the practice. So let's look on the back side of this sheet, because there's something else that we need to talk about as well, okay? So let's look at the top of this. Sorry for jostling the sheet there. So here it says consider LMN and PQR. So we've got 2 triangles again. It says LM is congruent to PQ. Well, we already know that again because there's the congruency mark. Sometimes they're just so obvious, right? And then it says MN is congruent to QR, which is here. And now it's saying then angle Q is greater than angle M. So we would know that. How would we know that? Well, because this side is greater than this side, right? So if this side is greater than that side, then that means this has to be a greater angle. I don't know what it is. I don't know what the angle is, but I know this one has to be greater, okay? So this is just the converse of what we kind of just went through. But this is actually going to be helpful to us, knowing that the greater angle is across from the greater side actually helps us to try to solve some problems. So what I want to do, I want to skip down. I want to look at number 3 here, and this will probably be our last one that we'll look at today. And then I'll show you what this practice looks like. So it says find the range of possible values for each variable, okay? Again, you notice congruency marks here. You notice congruency marks there, okay? And here we're given that this 58 right here, and then we're given this, okay? And you're like, what in the world? What am I going to do with that? Well, what I want you to think about is, notice the side that's across from it. You notice this side length here is 12, and this side length is 11. What does that tell us? This side is greater than this side, right? What does that tell us about these 2 angles? Well, if this side in this triangle is greater than this side in this triangle, then that also means that this angle has to be greater than that angle. So you guessed it. Here's the math that you're going to have to do. You're going to have to set up an inequality. So 58 is greater than 3x minus 2. Okay? So it might have been a while since you solved some inequalities. Well, welcome. We're using algebra in the middle of geometry. It doesn't make a whole lot of sense, but again, math is interconnected and interrelated, right? So here we go. Now we have this that we need to solve. So in order to solve this, I need to get this 2 across to the other side, right? I'm going to add 2 to both sides. And that is going to give me 60 is greater than 3x. And then, because this would go away, then I'm going to divide by 3. And so I'm going to move my work kind of over here a little bit. That gives me 20 is greater than x. Another way I can say that, I can rearrange these 2 terms and get x over here. Just remember I have I have to reverse my inequality. So this would be x is less than 20, okay? So that means that x has to be less than 20. In order for this to really be true, x has to be less than 20. But I want you to notice something else about this problem. It says find the range of possible values. Just like yesterday, when we found the possible range of values of one triangle, when we're working with two triangles, we're going to have more than one answer. So this is one part of our answer, but now I'm going to have to find the other part. Well, I want you to think about something. Think about it very carefully for just a minute. Can an angle be negative? So could this angle ever be equal to, say, -1? Well, no, we know that an angle cannot be negative, right? We also know that an angle cannot be 0, because if the angle is 0, that means it just doesn't exist, right? But 0 is the value for nothing. So we can think about this as an inequality. As a matter of fact, this can equal -2 or -3 or -4, anything on the negative spectrum. It also cannot equal 0. So what's an inequality that we can think about for this little term right here? This 3x minus 2, this angle that it's talking about. Well, we know it can't be negative and it can't be equal to 0, but what can we say? We can say that it has to be greater than 1. It has to be greater than 0, I'm sorry. So it could be 1 or greater. It could be 1 or 2 or 3 or 4 or 5, but we know that it cannot be 0. Okay, it's got to be greater than 0. So now what we do is we actually set this up as our other inequality. We set up 3x minus 2 is greater than 0, right? Because this says x is less than 20. Well, we just figured out that x cannot be -1 or it cannot be 0, and those are both less than 20. So there's got to be a range of values that this actually could be, all right? So watch what happens. I'm going to finish solving this. I'm going to go ahead and add 2 to both sides, this is going to cancel. It's going to leave me with 3x is greater than 2. And then to finish this out, I'm going to go ahead and divide by 3 on both sides. And now notice what it gives me. It gives me x is greater than 2/3. So here is my range of values for this particular answer right here. My x has got to be greater than 2/3. Otherwise, I don't even have an angle at all. And it's got to be less than negative or 20. X is less than 20. So these would be my two answers that I would have for number 3. Okay. I know that's a little bit cumbersome, a lot of math that you got to be able to do there. But again, you guys are in geometry sophomore year. I know that you're able to accomplish this. So let's look real quick at your practice. I want to just scan this real quick. So again, same type of problems we've been looking at. Write an inequality relating to given side lengths. So I have ST and MN that I'm comparing. Notice that I have similarities here, but notice that I have a 90-degree box here, which means this is 90 degrees. So let's think about a statement that we could make. Again, we'll just use what they have right there. ST and MN. What needs to go there? Again, it tells me to write an inequality, either a less than or a greater than. Is ST greater than MN or is it less than MN? Well, ST has a 90-degree angle across from it, whereas MN has a 57. So we know that that has to be greater than. And that's all you have to do. That's the answer right there. Okay? For 4 and 5, you got a couple of word problems. I'm not going to do those for you. I want you to take a stab at those. Number 6 is just like the one we did just a few minutes ago. Okay? So just to help you at least with the first equation or inequality, notice that this side is bigger than this side. That means this angle has to be greater than that angle. So my first equation I would need to solve for number 6 is going to be 75 is greater than x minus 13. Okay? And you would need to solve this. I'm not going to solve it for you. You would need to solve this and then think about it. The other thing that you know about this is that x minus 13 has to be greater than 0. Okay? So those would be the two equations you need to solve. This is not the answer. Let me repeat that. This is not the answers, but this is a start for you, okay, so that you can go ahead and finish it. You don't have to worry about number 9 at all. And then on the back side, we've got a whole page of goodness here, okay? So again, these you're just going to notice the instructions, copy and complete with either greater than or less than. You don't have to worry about explaining your reasoning. Just put me an answer there. A couple of 3-word problems, which you can do. And then last but certainly not least, you're just going to write an inequality that's going to represent angle A, angle F, angle L, angle R. And you're just going to use this information to help you try to figure that out. Okay, I'm really kind of leaving you at your own devices here a little bit, but I want you to be able to think and manage through this stuff. Again, if you need help, if you're truly stuck, then send us a private message, get a hold of either me or Miss Wheeler, and we'll be glad to try to help you out with this, okay? All right, do your best. This is the last section, guys. After this, we're going to be reviewing and testing, so hopefully this goes well for you. Thanks.